Hello everyone, my name is Kirti Ananalge. I am from Anasab Dange College of Engineering and Technology. I am here to present about the agent architecture in which we are going to focus on reactive agent architecture, deliberative agent architecture and hybrid models. So let's see and move forward to the objectives. So the objectives are to understand agent architecture and its fundamental, analyze reactive agent models, explore deliberative agent systems, study hybrid agent approaches, compare architectural paradigms, and let's go next to the definition of artificial intelligence in agent architectures in artificial intelligence. So, agent architectures Agent architectures in artificial intelligence refer to the structural design and organizational framework that defines how an intelligent agent processes information, makes decisions, and interacts with its environment. An intelligent agent is a computational entity that pursues its environment through sensors, processes information, and acts upon that environment through actuators to achieve specific goals. So, in agent architecture, AI refers to the structural design and organizational framework that determines how an intelligent agent processes information, makes decisions, and interacts with its environment. The way an agent pursues its environment, formulates internal responses, and acts on the external world is shaped directly by its architecture. Selecting an appropriate architecture is key for creating effective, robust AI system in diverse contexts. Let's move forward to the classification of agent architecture. Agent architectures can be broadly classified into three main categories: reactive, deliberative, and hybrid. Each category represents a different approach to balancing responsiveness, intelligence, and computational efficiency in agent design. So there are main three paradigms that are reactive, deliberative, hybrid. Further agents may have simple reflex agent, model-based reflex agent, reactive agents, goal-based agents, utility-based agents, deliberative agents, layered architectures, horizontal integration, hybrid agents, and that's it. So let's move forward to our first point, that is reactive agent architectures and its limitations. So what is reactive agents? Reactive agents are those which immediately respond to stimuli without planning. Their behavior is governed by simple condition action rules. This allows for fast, efficient responses, making them suitable for tasks like obstacle avoidance. However, reactive agents lack memory and cannot plan or reason about future consequences. So, the limitations of this reactive agent architectures are: despite their advantages, reactive architectures face several limitations like lack of internal world models can lead to suboptimal decision making in complex scenarios requiring planning or memory. Reactive agents may exhibit repetitive behaviors or fail to achieve long-term goals that require coordination of multiple actions over time. The purely reactive approach also struggles with tasks requiring deliberation, learning from experience, or adapting to novel situations that weren't anticipated during design. Next is, how is the agent environment interaction? The relationship between an agent and its environment is fundamental to understanding agent architecture. The environment provides stimuli through various channels, and the agent must interpret these stimuli, process them according to its internal architecture, and generate appropriate responses. So, what is actually the agent environment interaction? So, the agent operates through continuous interactions loops with their environment, and the sensor collects information or stimuli from the external world. Actuators allow agents to perform actions altering the environment. The core logic processes sensory input and decides the best action, driving the agent's autonomy and adaptability. So the main key points are environment. In the agent environment, in the agent environment interaction is environment, external context providing stimuli, agent, core entity processing information, internal architecture, structure guiding agent's actions, stimuli inputs from the environment. Now, the simple reflex agent. What is actually the simple reflex agent? It makes decision using condition action rules, same as the reactive agent. No internal state, so they only react to current perceptions. Ideal for fully observable environments, fast response times, but can fail for tasks requiring memory or learning. Example: a thermostat that activates heating based on temperature readings. So, model based reflex agent. What are the model based reflex agent that are? They have an internal representation or memory of the world. They update their state using new sensory data and past actions, able to handle environments that are partially observable. Example, a robot vacuum remembering clean regions and detected obstacles. It has limited awareness, only reacts to current percepts, internal state, maintains internal representation of the world. World model uses model to update internal state, action selection, chooses action based on updated state, enhanced awareness, reacts based on internal model. Let's go forward. Now, the topic is goal based agent evolution. So, what is goal based agent? Goal based agent have explicit goals, evaluating different actions based on how well they help achieve these objectives. It can reason about future consequences, more flexible than simple reflex and model based agent. Let's take an example of a chess program that evaluates moves with the aim of winning, looking ahead to future positions. So the key points in the goal-based agent are: reactive agent reacts to immediate stimuli, goal-based chooses action to achieve goals, goal definition, agent has explicit goals, action evaluation, evaluates actions against the goal. So the utility-based agents seek to maximize a utility function or performance measure. Consider a complex trade-offs and select actions yielding the highest utility suitable for environments where quantifying success helps in strategic decision making. The agents have utility functions that measure how good a particular state is. They choose action that maximize their expected utility, allowing them to handle conflicting goals and make trade-offs. Some key points in the utility based agents are: complex but ineffective, struggles with complexity despite low utility, simple but ineffective, lacks utility and avoids complex trade offs, optimal strategy, maximizes utility with complex trade offs, simple and ineffective, it achieves high utility with minimal complexity. Next is learning reactive agent. Learning reactive agents, this agent can modify their reactive behaviors based on their experience, though they still respond reactive, reactively to immediate stimuli. They adapt their condition action rules or behaviors patterns over time. The characteristics are: adapt behaviors based on experience, may use reinforcement learning or other learning mechanisms, maintain reactive response time while improving performance. Example, a trading bot that adjusts its buy or sell based rule based on market performance feedback while still making rapid trading decisions. So the key points in the learning agent is: evaluate performance. Agent assesses effectiveness of new behaviors, apply new rules. Agents use updated rules and interact. Receive stimuli. Agents react to immediate stimuli. Modify behavior. Agents adjust rule based on experience. So to sum up, learning reactive agent, that some reactive agents can learn and adapt their condition action rules over time based on their experience. So the comparative analysis of deliberative and reactive agents. So the reactive agent have efficient for immediate responses and simple tasks. It has immediate and effective responses and efficient responses. It has simple design. It does not plan or reason. Whereas, on the other hand, the deliberative excels in complex reasoning and long-term planning. It maintains internal models, plans ahead, and adapts strategies, and it handles complex goal-based tasks. Reactive agents are ideal for fast reactions, whereas deliberative agents are suited for tasks involving foresight and reasoning. Let's move forward to the hybrid agent architecture. Hybrid agent architecture combines fast reactive responses with strategic deliberative planning. The pros and cons are the pros are it has balanced, achieves optimal performance across diverse. Flexibility adapts dynamically to changing environmental conditions, combines approaches, integrates reactive and deliberative strategies effectively. Modular optimization allows tailored enhancements for specific modules. Complex applications handle integrate real world applications efficiently. The cons are implementation complexity requires advanced skill for setup and management. Coordination challenges demand precise synchronization between components. Behavioral conflicts may lead to conflicting reactive and deliberative actions. Computational overhead, increased processing load due to coordination mechanism. Complex testing necessitates comprehensive testing strategies. So the next is challenges in deliberative agent architecture. Deliberative agent architecture faces difficult problems like qualification problem, anticipating all possible condition, handling dynamic real-time environments, computational burden from maintaining large internal models, potential inaccuracies in world modeling. The agent architectures range from immediate reaction to strategic planning. It goes from reactive to deliberative. In the middle, it has hybrid. Agent architectures range from immediate reaction through strategic planning, that is deliberative, with hybrid models in the middle. This spectrum enables selection of the best model based on the complexity and demands of the task. Hybrid approaches integrate the virtues of both of example, combining rapid obstacle avoidance with planning in robotics. The agent architectures applications. The applications of agent architectures are robotics and autonomous systems, game AI and virtual characters, robotics and autonomous systems, self-autonomous and vehicles. Agent architecture are foundational to building intelligent agent, and it also has some other applications like financial trading, autonomous vehicles, mobile robots, smart home systems, in which the financial trading requires reactive responses and deliberative planning. The mobile robots use hybrid approaches for obstacle avoidance and destination planning. Smart home systems has to perform reactive control for automation tasks. So, last but not least, the conclusion. Agent architecture are foundational to building intelligent agents in AI. Their selection shapes the way systems perceive, decide, and act. Reactive, deliberative, and hybrid models each offer unique strengths and limitations. Modern intelligent systems often blend these paradigms for the best combination of speed, adaptability, and strategic behavior. So the reactive agents, the conclusion has some key points that are reactive agents, distributed agents, intelligent agents, and natural synthesis integrate, in which the reactive agent has limited learning and reasoning and learning. Distributed agent has network span edge to cloud infrastructure. Adaptive intelligent agent has fast, consistent, and agents versatile. Neural synthesis integrate learning with reasoning. Thank you for listening to my podcast. Thank you.